Hello everyone, welcome to 722 day 1. Today we're going to be talking about finding parameters of trig functions from their graphs. So when we talk about those parameters, we're talking about essentially A, H, and K, the amplitude, the phase shift, and the midline of our trig functions just by looking at the graph. So we're really going to dig into those graphs today. All right, so we want to make sure that we review the graphing forms of sine and cosine, and then we want to make sure that we understand how to find A, H, and K from those graphs, and then use that information to help us write the equation of a sine or cosine function from that graph. All right, so we're going to go ahead and jump right into it here. We are looking at our graphing forms here. This is what we've covered the last 4 days, pretty much all of last week. We talked about this, the graphing forms here. So they both look very much the same. The only difference is the cosine versus sine, but A, H, and K all fall in the same locations for sine or cosine. It doesn't really matter which trig function we're using. And A, H, and K all control the same thing with the graph. Okay, so this A value that we see here controls the amplitude, right? And the amplitude is essentially the distance from the midline to the highest point on the graph, right? Which is our stretch and compression of the function. So if I want to stretch our sine wave or our cosine wave and make it skinnier or wider, this is the parameter that we change. All right, the phase shift, which is controlled by the h value inside of the parentheses, controls left and right movement. So if I want to take my wave and I want to slide it to the right or slide it to the left, this is the parameter that controls that. And then the k value on the end here outside of the parentheses, this value outside here is what controls the location of the midline, right? The midline being the line that splits the graph horizontally. All right, and it essentially controls the up and down movement of the function. So if I want to take my wave and I want to shift it up a couple of units or shift it down, this is the parameter that we would change, and that's going to be true for either the cosine or the sine function. It doesn't matter which one. All right, the last control or the last part that we're talking about here is what's called the reflection. Right, and so if that a value in front, right, so if we look at this a value, if I were to put a negative in front of that a value, that would take my sine wave and flip it or reflect it over the x-axis. All right, so we're going to practice finding these things in some graphs. So we've got some graphs on here that we're going to take a look at, and we're going to find these things and hopefully write an equation using that information. Okay, so here we go. All right, so we have a graph here, and the first place that I like to start is just by identifying whether or not it is sine or cosine, and to do that we need to take a look at the midline, right? So how do I know if I'm looking at a sine or a cosine wave? So I like to first identify where the midline is going to go, and the way that I do that is I look at the graph and I say, okay, well, how high does the graph go? And I notice like this particular graph goes as high, and when I say high, I mean how high on the y-axis, right? So the highest point on the y-axis here is at 3. Right, so this is as high as it goes, and then I like to look for how low it goes. So if I'm riding this thing like a roller coaster, the lowest point occurs right here, and that's at a value of -1. All right, so it goes as high as +3, as low as -1, and we would be looking for the midpoint between that high and that low, that min and that max. Okay, so the number that is at the midpoint in between -1 and 3 is +1. Right? Because if you count it up, you go 1, 2, 3, 4, right? There's a distance of 4 in between that min and that max. So if I go a distance of 2, that would take me to the midpoint height-wise of that wave, right? So the midline is located right here. This is the line that splits the graph in half horizontally, right? So this is what we would call the midline. Okay, and so we found that midline, and we're going to say that the midline is at y equals 1. All right, we always write the midline as an equation, and since we need an equation, the equation of a horizontal line is always y equals some number, and it's always where that line crosses the y-axis. So it's y equals 1 for the midline. All right. Now I can figure out whether or not it is a sine or a cosine, because when I go to 0, right, when I go to an x value of 0, I look at the midline and I ask myself, does the function start on the midline or does it start off the midline? Since this one starts off of the midline, we know it is a cosine function. Okay, cosine starts off the midline, right? And since I can see this one is not on the midline at 0, it is cosine. All right, so now we have the midline. We know it's a cosine function. Well, let's find the amplitude. The amplitude is the distance from the midline to the highest point. Right, so here's my midline, and if I go straight up to the highest point from the midline, right, so I'm going up to that highest point, this distance right here that I just drew in, that is the amplitude. So that is a distance of 1, 2, right? And the amplitude is always going to be a positive value. All right, so you don't have to worry about it being negative, since the amplitude is the measure of a distance, right? Distance is never going to be negative, so this is a positive 2. All right. Now the question is whether or not it has been reflected. This is a cosine function. It has not been reflected. If it had been reflected, it would start below the midline, not above it. So this one has not been reflected. And then we talk about this thing called the period. All right, and the period is the horizontal distance to complete one cycle. All right, so one cycle of cosine. All right, we've seen the original cosine wave back in previous lessons. We know that one cycle of the cosine wave, it starts up, it goes down, right? So it makes this valley-looking shape in one cycle, kind of like that, right? And this is where it would complete the ride. You'd go up, down, back up, and then it's going to repeat that same process. It's going to go down, back up, over and over and over again. So this is one cycle of cosine and what one cycle of cosine looks like. So the horizontal distance that it covers in one cycle, that is the period, right? So it starts here and horizontally goes from here to here, and this is where it starts to repeat itself again, right? So it starts at 0 and ends at 2 pi. So that means that one period is 2 pi. Okay, this is the horizontal distance to complete one cycle. All right, so now we're going to go over here. We're going to write our equation. So remember, our equation looks like this. Since it's a cosine function, we have y equals a times cosine x minus h plus k. And for these types of problems, we're not going to be doing any horizontal shifts, so you can always assume that h, the value inside of this parentheses here, is always going to be 0. Okay, so here we go. We did find the amplitude, right? So if I'm writing my equation down here, we found the amplitude of our cosine wave here to be 2. So we're going to say 2 times cosine x. Remember, we said h is going to be 0. And then whether we need to look at whether or not that midline moved. Right, so since our midline is at 1, we need to put a plus 1 on the end. So this becomes the equation of our cosine function that we see in the graph. We accounted for the amplitude, we accounted for the midline, and we accounted for whether or not it was sine or cosine, and we looked at whether or not it was reflected. Okay, and all of that is expressed here in the equation. All right, let's try it again for another one. So first I'm going to start off with the same thing. I'm going to find the midline. So I'm looking at the highest point is right here, right? So it's got a highest point at 1. And then I'm looking at the lowest point happens here and here, right? This one actually has 2 low points that I see, and that happens at -1, right? So the number directly in between 1 and -1 is 0, right? So this is where my midline would be right here at 0. So I'm going to draw in my midline. Right. So there we go. Midline. Oops. And that's going to be at y equals 0, and I can write that down here as well. All right, so we got y equals 0. Now I'm going to figure out whether or not it's sine or cosine. So here's 0. I'm looking at the midline, and it looks like my function starts off the midline again. So this is certainly cosine. And let's do the amplitude, right? So here's my midline, here's my highest point. I just need to draw in that distance going directly from the midline up to that highest point. So I'm going from here to here. There's my amplitude. and that has a distance going from 0 to 1, so the amplitude is going to be a distance of 1. All right, so let's see, has it been reflected? Well, I know a cosine function normally starts above. This one is starting below, so yes, this one has been reflected. And if I were to compare this graph to my last one, you can kind of see that valley kind of goes down, right? It kind of makes a valley, but this one is making a hilltop, right? So it's like that shape has been flipped upside down, and that is exactly what a reflection would do. So there's definitely a reflection going on here. Let's take a look at the period. All right, so this is where I like to kind of grab my highlighter. I want to highlight one full cycle of cosine. All right, so I'm going to get that entire hilltop, and then I know, so I'm starting down, I go up, I come back down, and then I'm going to do the same thing again, right? So I try to figure out, I go through one full cycle and I try to figure out when it repeats that same thing again. So this one is going from 0 to 2 pi, right? So this is where it starts to repeat itself. This is where it starts at 0 and then starts to repeat itself at 2 pi. So its period is 2 pi. All right, so I'm going to write my equation again. So remember our template for the equation, right? So for a cosine function, we're going to say a times cosine. We're just going to put an x in here instead of an x minus h because we're not doing any horizontal shifts or phase shifts. So we'll just let x be inside of the parentheses and then plus k. All right, so we've got y equals, let's see, amplitude was 1. So we'll just say 1 times cosine x. And then the midline was also at 0, so we'll say plus 0. And then it has been reflected, so I need to put a negative in front of the 1. So I can simplify this a little bit, and I can just say y equals negative cosine x. And then since it's a plus 0, I really don't need to write that on the end. And that completes that problem. All right. Let's try another one. Okay, so this one's a little bit different because they give us the equation right from the get-go. So we can see right away this is a sine function, so we don't have to worry about finding that. But let's see if we can find some of the other parameters in this graph. So I'm going to start the way that I started the other ones. I'm going to start with the midline. Okay, so I go to the highest point and I look at that y value at the highest point. It's at 3. Right, so it gets as high as 3, and then we have the lowest point down here at -1. Right, so if I were to count up from -1 to 3, right, that'd be 1, 2, 3, 4, and I want to go halfway, right? So I'm going to go 1, 2. So this is where my midline would be, right? The horizontal middle of the graph. Okay. So that is the midline, and that is located at y equals 1. Right, I can see that horizontal line passes through 1. All right, so now I can find the amplitude, right? So here's my highest point, and I'm going to go from my highest point straight down to my midline, and then I count, right? So 1, 2. So it's got an amplitude of 2. And then we're going to trace out a period here. So remember, we want one full cycle, and you have to kind of think back to the original graph of sine, right? We know it goes up, goes down, comes back up. So it makes like that serpentine figure. So we're going to go up and down and then back up, right? So there is one full cycle of sine. And we start here at 0. And we're going to trace a horizontal distance from 0 until we get to the end of that cycle. And we stop right here. And that is at 2 pi over 3. All right, so one period is 2 pi over 3. All right, so that one was nice. We didn't have to write an equation on that one or determine if it had been reflected, because we'd be able to see the reflection right in the equation. If there was a negative out front here, then we would know it had been reflected. We can see it's a sine just by looking at its equation. But the other parameters we were able to find from the graph. Okay. All right, let's try one more here. So this one has it all, right? We got to find all the stuff. They did not give us an equation this time. So let's get right to it. Let's start with the midline like we have before. So I'm looking at the highest point. Looks like that's located right here. Let me grab a different colored pen for this one. I'm going to go green, right? So the highest point is right here. It's as high as it goes, and that happens at 2. And then the lowest point looks like it's right here, and that happens at -2. So the number halfway in between -2 and 2 is right here, right, at 0. So we're going to go here. I'm going to draw in my midline. There we go. So midline at y equals 0. Okay. Let's see, is this a sine or a cosine function? So I'm going to 0. I'm looking at my midline, and notice this function starts on the midline, so this is a sine function. All right, remember, cosine either starts above or below it. Sine starts right on it. Okay. Now let's do the amplitude. So here's my highest point. I'm going to draw the distance from the highest point directly down to the midline. So we're going from 2 down to 0. So that is a distance of 2 for the amplitude. Okay. And we're going to trace out a period. Right. So we'll get one full period here. So remember, sine goes up, back down, and then back up. Right. It makes that nice little serpentine wave. So there's one full cycle. And again, if I trace out the horizontal distance from the beginning of the cycle to the end, we start at 0 and we go all the way to 2 pi. Okay, so we have a period of 2 pi. All right, so now I'm going to write my equation. Remember, sine kind of looks like this. We have a sine, and we're just going to put an x in there. Remember, no horizontal shifts, no phase shifts in this, so we'll just leave it as x inside the sine function, and then plus k here on the end. All right, so we found our amplitude to be 2, so I'm going to say y equals 2 times sine of x. And then our midline was at 0, so we could say 2 sine x plus 0. We said, well, we never talked about whether or not it was reflected. So normally from sine, from the beginning, sine starts by going up, right? So this one does go up, but if it had gone down instead, so if it had gone this direction, we would have known that it was reflected. Okay, so this one goes up, so it was not reflected. That means I do not need to put a negative in front of the 2. So I can simplify this just a little bit. I can say y equals 2 sine x, and I really don't need to write the plus 0 on the end. And that completes my equation. All right, guys, that is it for today. Give the practice problems a try, and of course, if you have questions, just let me know in the Zoom chat. Have a great day.